Welcome. Our today's topic is boost converter. And what is the use of boost converter? Boost converter is used to step up the voltage. Okay. So I am going to discuss the operation of boost converter and some important formulas I am going to show you also, which are very useful to solve the numerical problems regarding the boost converter. Okay. In the GATE examination and in any other competitive examination, the questions are frequently asked from the topic of boost converter. Okay, so I already told you boost converter is used to step up the output voltage. So obviously the output voltage VO will be greater than the supply voltage VS. So how we can get this concept from the volt second balance? Volt second balance means what? Voltage across the inductor, the average voltage. Okay, the average voltage across the inductor is 0. Okay, you know the concept. So look at this is the inductor and this is the power electronic switch, this is the diode and capacitor. These are the main components of chopper. Boost converter is one type of chopper. Okay, so now see here, when switch is on, I mean if we turn on the switch, means this will be shorted. So in that case this will be the direction of current flow. So if we apply the KVL in this loop, Vs equals to VL. We are considering the voltage across inductor as VL. Okay, so when on means the switch is on, in that case VL, voltage across the inductor, is equal to the supply voltage. And when the switch is off means this is open circuit. So this will be the direction of current flow. The diode is forward biased, so current will flow through the diode. So in that case the voltage across inductor is supply voltage minus the output voltage, that is shown here. Okay, so we are considering the switch is on for t on time and switch is off for t off time. And D is very important. D is called the duty ratio. D equals to t on by t. T means the total time. On time or total time, that is duty ratio. So obviously t1 equals to dt and t off equals to 1 minus d into t. So look at this line. Vs multiplied by t on, so Vs multiplied by dt, that will be equal to Vs minus Vo multiplied by 1 minus d into t. So if you simplify the equation, finally we will get Vo equals to Vs divided by 1 minus d. D is the duty ratio. So if we consider the any value of d, obviously d equals to t on by t, so it will be less than 1, as because less than or equal 1, as because the turn on time can't be greater than the total time. Okay, so turn on time will be always less than equal the total time, so d will be less than equal 1. So suppose we consider the value of d equals to 0.5. In that case the output voltage Vo equals to Vs divided by 1 minus 0.5, that is 0.5. So you can clearly see from this equation that the output voltage is higher than the input voltage. Okay, now go to the ampere second balance. Ampere second balance means what? Volt second balance means the average voltage across the inductor is 0, and amp second balance or ampere second balance means the average current flowing through the capacitor will be equals to 0. So when the switch is on, in that case this is shorted, so the current here is 0. So if we apply the KCL at this node, IC plus IO equals to 0. So IC means the capacitor current will be equals to minus of IO, that means output current. See here, when switch is on, IC equals to minus IO. And when switch is off means IS is here. Okay, so if we apply again the KCL at this node, this is supply current IS or IL, both are equal. The supply current is flowing through the inductor, so IS equals to IL. So IL equals to IC plus IO, that is IC equals to IL minus I naught. Okay, now on time is T on means dt, and off time is 1 minus t into T. So after the simplification of this equation, we are getting IO means average output current equals to IL multiplied by 1 minus d. Okay, up to this is clear. Now we have to find out the critical value of inductance. Critical value of inductance means what? You know that inductor opposes the sudden change of current, so the inductor will charged when the switch is on, then the inductor will discharge when the switch is off. So charging and discharging means inductor current will look like this. Okay, for the simplification we are considering the straight line. Suppose this is the average value of inductor current. Okay, so this is the minimum value of inductor current, this is the maximum value of inductor current. Suppose this is the zero value. Okay, this is the zero value. So the difference between maximum inductor current and minimum inductor current we are considering as delta IL. Okay, critical value of inductance means for the value of inductance, means for which value of inductance the inductor current will be just continuous. Just continuous means what? It will start from zero value and after discharge it will reach at zero value. So inductor current will look like this. If we decrease the value of inductor current, means if we decrease the value of inductance from the critical value, in that case that will be in discontinuous conduction mode. Okay, now we are going to calculate the minimum value of inductance for which the inductor current will be just continuous. How to calculate? Suppose average value of inductor current is IL. Okay, so average value of inductor current minus del IL by 2. Del IL is the difference between maximum and minimum inductor current. For which value of inductance this equation will satisfy, that value of inductance is the critical value of inductance. Okay, now from this equation, look at this, from this equation we know that IL equals to IO divided by 1 minus d. Okay, so this equation will become this equation. Okay, now see here, we know that voltage across inductance VL equals to current through the inductance L multiplied by di dt. Okay, rate of change of current with respect to time. So when the switch is on, in that case the voltage across inductor is equals to Vs, that is the supply voltage. Now in that case change of inductor current, that is del IL, means the difference between maximum inductor current and minimum inductor current, and dt change of time. Change of time is nothing, change of time is T on. For the T on time the inductor current will reach from minimum to maximum. See again. Okay, look at this again. This time is nothing, the T on. For T on time the inductor current will reach from minimum to maximum, and the difference between maximum and minimum inductor current, that is del IL. Okay, so come here, come. When the switch is on, Vs equals to L del IL divided by dt. Dt is the T on, turn on time. So from this equation, del IL will become Vs equals to, we know that Vo equals to Vs by 1 minus d. I already derived this equation. So Vs equals to Vo multiplied by 1 minus d, and dt will multiplied with this. So this equation will come. So from this equation, see here, we have to satisfy this equation to get the critical value of inductance. Okay. So del IL by 2, del IL is this much. This should be equals to, del I should equals to 2IO divided by 1 minus d. Okay, this is true. Now after the simplification of this equation, we are getting critical value of inductance equals to R divided by 2F into 1 minus d square multiplied by d. R is the value of the resistance. R is the value of the resistance. Output voltage VO equals to IO, that is output current, multiplied by the resistance. Okay, so that's why I replace the VO by IO multiplied by the R. Now the critical value of capacitance, same concept. Capacitor will charge and the capacitor will discharge again. For the simplification, we are considering the state line, means linear charging and discharging, and the voltage difference between maximum voltage of capacitance and minimum voltage of capacitor, the difference is del Vc. Okay, difference is considered at del Vc, and the average value of capacitance, that is nothing the output voltage. Why? Because the capacitor is connected across the output terminal. So voltage across capacitor and the output voltage, means voltage across load, both are equal. Now come here. For the critical value of capacitance, the value of capacitance C should be in such that the capacitor voltage will be just continuous. Means same thing again. It will charge, it will discharge again, like this. So for that purpose, the average output voltage, means the average voltage across capacitor, both are equal. That should be equals to del Vc divided by 2 from here to here. Okay, so you know that current through the capacitor equals to C dV dt. C dV dt. I am considering the when the switch is off. Okay, when the switch is off, see here, when the switch is off means this is open circuited. So at that time the capacitor will be charged by the supply voltage. When the switch is on, in that case it is shorted, so the capacitor will discharge through the load at that time. So we are considering the off state here. When the switch is off, at that time the current through the capacitor is supply current minus the output current. Okay, that equals to C dV dt. C multiplied by change of capacitor voltage, that is considered as del Vc, means minimum value of capacitance and maximum value of capacitance. The difference is del Vc, divided by del T or dt, that is the change of time. Change of time is nothing but T off, and T off is equals to 1 minus T into T. And you know that the Is or IL, that equals to IO, output current, divided by 1 minus T. So if we put this equation here, it will give Is minus IO equals to IO into D by 1 minus D, that equals to this. Now from this equation, 1 minus D are cancelled from both sides. So del Vc equals to IO dt divided by C. So if we put the value of del Vc in this equation, that will give IO multiplied by R. output voltage equals to output current multiplied by the load resistance, that equals to del Vc divided by 2. So C equals to dt by 2R. So these equations are important, which are marked here, tick mark is given here, and this circuit diagram you have to remember. So if you remember all of this, you can solve the questions regarding the boost converters very easily. Okay, in the upcoming videos I will discuss about the buck converter and the buck boost converters also. Thank you.